Welcome to the Oracle's Rest, a place where stories unfold slowly, where time softens, and where the mind is free to wander. Tonight, we drift outward into the quiet expanse of space and into the distant, steady light of the stars, not as points in the sky, but as physical objects, immense, luminous, and shaped by forces that operate far beyond everyday experience. A star is not simply a source of light, it is a sustained process. At its core, a star exists because gravity and energy are held in balance. Gravity pulls inward, drawing matter toward the center. At the same time, energy generated within the star pushes outward, resisting that collapse. This balance is not static. It is maintained through constant interaction, a continuous exchange between inward pressure and outward force. The energy that supports a star comes from nuclear fusion. At extremely high temperatures and pressures, hydrogen atoms are forced close enough together that they combine to form helium. This process releases energy, not in a sudden burst, but as a steady output, sustained over long periods of time. The energy travels outward, moving through layers of dense plasma, eventually reaching the surface. From there, it is released into space as light and heat. What appears from a distance as a small point in the sky is in reality a massive, ongoing reaction. The sun, the closest star to Earth, contains more than 99% of the mass in the entire solar system. Its diameter spans over 1,000,000 kilometers. Its core temperature reaches millions of degrees. And yet, from Earth, it appears as a contained disk of light. Other stars, though often much farther away, follow similar principles. They vary in size, in temperature, in brightness, but the underlying process remains the same. Some stars are smaller than the sun, burning more slowly, conserving their fuel over longer periods. Others are far larger, consuming their energy at much higher rates, existing for shorter spans of time. The color of a star is determined by its temperature. Hotter stars emit light toward the blue end of the spectrum. Cooler stars emit light that appears red or orange. This difference is not a surface feature. It reflects conditions deep within the star. Blue stars, which appear bright and intense, are often among the hottest. Their energy output is high, their lifespans relatively short. Red stars, cooler in comparison, burn more slowly. They can exist for much longer periods, sometimes far exceeding the lifespan of more massive stars. From Earth, stars appear fixed in place, but this stillness is an illusion, created by distance. Each star is in motion, moving through the galaxy, following paths shaped by gravity. The distances between stars are so vast that their movement becomes difficult to detect over short timescales. Light itself takes time to travel. When you observe a star, you are not seeing it as it is now, but as it was when its light began its journey. For nearby stars, this delay may be only a few years. For more distant stars, it may be hundreds or thousands or more. This means that the night sky is not a single moment in time. It is a collection of past states, each star representing a different point in its own history. Some stars, you see, may no longer exist in the form they once had. They may have changed, expanded, or ended their life cycles entirely, while their earlier light continues to travel. Stars do not form in isolation. They begin within large clouds of gas and dust, known as nebulae. Within these clouds, regions of higher density begin to collapse under gravity. As matter gathers, pressure increases, temperature rises. Eventually, conditions become sufficient for fusion to begin. At that point, a new star is formed. The surrounding material may remain as a disk from which planets can eventually form. This process is gradual. It unfolds over long periods, not in sudden events. From a distance, star formation appears calm. There are no audible signs of its progression, only changes in light and shifts in structure. Stars can also exist in systems. Binary stars, for example, consist of two stars orbiting a common center of mass. Their motion is governed by their combined gravitational influence. In some cases, these stars are close enough to affect one another directly. Material may flow from one star to the other. Energy output may vary as a result of these interactions. Yet even in such dynamic systems, there is no sound. The motion is real, The forces are significant, but the environment does not allow for vibration to propagate. Star clusters are another common structure. These are groups of stars that formed together from the same cloud of material. They remain bound by gravity, moving through space as a collective. Within a cluster, distances between stars are smaller than average, but still far too large to support any continuous medium. The stars interact through gravity, not through sound. Even in regions where stars are densely packed, the silence remains. Light moves between them, carrying information, but nothing carries vibration across those distances. The sky, then, is filled with objects that are active, dynamic, and constantly evolving, but none of them communicate through sound, only through light and through the slow, steady influence of gravity. And as you continue to observe, to imagine these distant stars, their structure, their motion, their quiet existence, the sense of distance grows, and with it, a deeper awareness of just how vast and how still the space between them truly is. The light that reaches you from a star is not immediate. It does not appear at the moment it is produced. Instead, it begins a journey from the core of the star, where energy is first created. That energy does not move directly outward. The interior of a star is dense, opaque, filled with particles that constantly interact. Photons, the particles of light, are absorbed, re-emitted, scattered in new directions, over and over again. This process is slow. A photon produced in the core may take thousands or even hundreds of thousands of years to reach the surface. Its path is not straight. It moves in a random pattern, gradually working its way outward through layers of matter. By the time it escapes the surface, its original direction has been completely lost. What finally leaves the star is not a direct line from the center, but the result of countless interactions. Once it reaches the surface, the conditions change completely. There is no longer dense material to obstruct its path. The photon enters space and begins to travel freely. From that point forward, its motion is simple. It moves in a straight line at a constant speed. unaffected by any medium. This speed, the speed of light, is the same everywhere. It does not depend on the motion of the source or the observer. It remains constant, regardless of direction or location. This consistency allows light to carry information across vast distances. The brightness of a star depends on two main factors. The first is its intrinsic luminosity, how much energy it produces. The second is its distance. As light travels outward, it spreads. The same amount of energy is distributed over a larger area. This causes the intensity to decrease. A star that is very bright but extremely distant may appear faint. A closer star, even if less luminous, may appear brighter. This relationship is described by the inverse square law. As distance doubles, the intensity of light becomes 4 times weaker. As distance increases further, the reduction continues. This is why most stars are not visible to the unaided eye. Their light reaches Earth, but at such low intensity that it blends into the darkness. Telescopes allow us to collect more of this light by gathering photons over a larger area. They make faint objects visible. They do not amplify the light, but increase the amount that can be detected. This reveals structures that would otherwise remain unseen. Stars are not distributed randomly. They are arranged within galaxies, vast systems containing billions or even trillions of stars. Our own galaxy, the Milky Way, is a spiral structure. Its stars are organized into arms curving outward from a central region. The Sun is located within one of these arms, far from the center. From our position, we see the galaxy from within. This creates the appearance of a dense band of light across the night sky. This band is composed of countless distant stars, their light blending together. Each point of light is a separate source, but at great distance. They merge into a continuous glow within galaxies. Stars follow orbits. They move around the galactic center, influenced by the combined gravity of all the mass present. These orbits are not perfectly circular. They vary in shape, in speed, in orientation. Over long periods, stars change position. But because the time scales are so large, these changes are not noticeable. Over a human lifetime, the apparent patterns of constellations remain stable. Constellations are not physical groupings. They are patterns defined by perspective. Stars that appear close together in the sky may be separated by vast distances in space. Their alignment is temporary, based on the viewpoint from Earth. As stars move, these patterns will eventually change, but the process is slow, so slow that the shapes remain recognizable across generations. Stars also differ in their stages of life. A newly formed star begins in a stable phase where fusion of hydrogen provides a steady output of energy. This stage can last for millions or billions of years. As hydrogen is used, conditions within the star change. The core composition shifts, pressure and temperature adjust, and new processes begin. Some stars expand into red giants, their outer layers extending outward. Others may shed material, forming surrounding clouds. More massive stars undergo more complex transformations. They may fuse heavier elements, progressing through stages that produce different outputs of energy. Eventually, fusion can no longer be sustained. At that point, the balance between gravity and energy is lost. The star changes form. The exact outcome depends on its mass. Some stars collapse into dense remnants. Others end in energetic events that reshape their surroundings. But regardless of the outcome, the processes occur without sound. Energy is released. Matter is transformed. But the environment does not support vibration. The universe remains quiet. Even as stars evolve, change, and eventually end their cycles, their presence is defined not by noise, but by light, a steady transmission of energy moving across space, revealing structure without ever creating sound. And as that light continues to travel, crossing distances that stretch beyond imagination, it carries with it a record of processes that are constant, complex, and entirely silent. Stars do not exist in isolation from their surroundings. The space between them, though often described as empty, contains matter. This matter is not distributed evenly. There are regions where gas and dust become slightly more concentrated. These regions form the raw material from which new stars emerge. Interstellar gas is primarily hydrogen, the simplest and most abundant element. Mixed within it are traces of helium and heavier elements formed in earlier generations of stars. Dust particles, microscopic grains of carbon, silicon, and other materials are also present. These particles interact with light. They can absorb it, scatter it, or allow it to pass through. This affects the way distant stars appear. In some regions, dust blocks light, creating dark patches against brighter backgrounds. In others, it reflects or emits light, producing faint glowing structures. These structures are often referred to as nebulae. Nebulae vary in form. Some are dense and compact, others diffuse and extended. Some emit light, while others remain dark. The behavior of a nebula depends on its composition, its density, and the presence of nearby energy sources. In star-forming regions, gravity plays a central role. Small variations in density can grow over time. A slightly denser region attracts more matter. As more matter gathers, its gravitational pull increases. This leads to further accumulation. The process continues, gradually amplifying the initial difference. As material collapses inward, it becomes more compact. Pressure increases, temperature rises. Eventually, a dense core forms. Around this core, material may begin to rotate. Conservation of angular momentum causes the collapsing cloud to flatten into a disk. Within this disk, smaller structures can begin to form. Some of this material may become planets, asteroids, or other objects. At the center, the forming star continues to contract. As it contracts, its temperature increases. When the core reaches a critical point, nuclear fusion begins. This marks the transition from a collapsing cloud to a stable star. The surrounding disk may persist for some time. Gradually, material is cleared, either accreted onto the star or dispersed into space. The result is a system centered on a newly formed star. Throughout this entire process, there is no sound, even though matter is moving, colliding, interacting. The environment lacks the continuity needed to carry vibration outward. The interactions remain local. Energy is exchanged through radiation, through particle motion, through gravitational influence, but not through sound waves. The formation of stars is therefore a quiet process. It unfolds over long timescales without any audible indication. Only changes in light and structure reveal what is occurring. In regions where stars have already formed, their presence influences the surrounding space. Radiation emitted from stars can heat nearby gas, altering its state. Ultraviolet light can ionize atoms, removing electrons and changing the behavior of the material. This creates regions of ionized gas, often visible as faint glowing areas. Winds from stars, streams of charged particles can also shape the environment. These stellar winds push against surrounding material, compressing it, clearing cavities, and influencing the formation of new structures. Again, these interactions involve motion, force, and energy transfer, but remain silent. There is no medium to convert these forces into sound. The interstellar medium, though not completely empty, is far too diffuse. Particles are separated by large distances. Collisions occur, but not in a coordinated way. That would produce a wave. Even shock fronts, regions where pressure changes rapidly, do not generate sound in the way they would in a dense environment. They move through the medium, compressing it, heating it, but the resulting motion does not propagate as audible vibration. Instead, it is observed through changes in light. Astronomers detect these effects by measuring shifts in radiation. Spectral lines, which correspond to specific elements, can reveal motion. If a gas cloud is moving toward us, its light is shifted slightly towards shorter wavelengths. If it is moving away, the light shifts toward longer wavelengths. This is known as the Doppler effect. It applies to light in a similar way that it applies to sound, but in space, only the light-based version is present. There is no equivalent shift in sound because there is no sound to begin with. The structure of space is therefore mapped through light, through subtle variations in brightness, color, and motion. These variations provide information about temperature, composition, velocity, and distance, all without any reliance on sound. The universe communicates through these signals, not through vibration in a medium, but through radiation and the movement of matter. Even in regions filled with activity, where gas flows, stars emit energy, and structures evolve, the silence remains, not because nothing is happening, but because the conditions for sound are never fully met. And as these regions continue to change, as stars form and influence their surroundings, the quiet persists, unchanged, stretching across the space between them, carrying no vibration, only distance. Not all stars exist alone. Many are part of systems where two or more stars are bound together by gravity. In a binary system, two stars orbit a common center of mass. Their motion is not one star circling the other, but both moving around a shared point. The location of that point depends on their relative masses. If one star is much more massive, the center of mass lies closer to it. If their masses are similar, the center lies between them. This motion is continuous, governed by gravity, and maintained over long periods. In some binary systems, the stars are widely separated. They orbit slowly, taking years or even centuries to complete a cycle. In others, the stars are much closer. Their orbits are faster, their interactions more direct. When stars are close enough, they can influence each other in ways that alter their structure. Material from one star may be drawn toward the other. Gas can flow across space, forming streams, accretion disks, and regions of intense energy release. These interactions involve motion, pressure, and energy transfer. In a dense medium, they would produce sound, but in space, they remain silent. The motion is real. The forces are strong, Yet there is no medium to carry vibration outward. Binary systems can also produce observable changes in brightness. If the orbit is aligned in a certain way, one star may pass in front of the other. From our perspective, this causes a slight dimming as the stars move. The brightness changes in a regular pattern. These are known as eclipsing binaries. The variation in light provides information about the size, distance, and motion of the stars. Even here, the information is carried by light, not sound. There are also systems with more than 2 stars, triple systems, and even larger groupings can exist. Their motion becomes more complex, with multiple gravitational influences acting simultaneously. Yet, the underlying principle remains. Gravity defines the paths. Energy shapes the interactions, and silence remains constant. Beyond individual stars and systems, there are larger structures that organize them. Open clusters contain relatively young stars that formed together. They are loosely bound, and over time, they may disperse. Globular clusters are more tightly bound. They contain older stars, packed into a spherical distribution. These clusters orbit the center of a galaxy, moving as a single unit. Within them, stars are closer together than in most other regions. Distances are reduced, but still far beyond what is needed for a continuous medium. Even in these dense environments, sound does not propagate. The stars interact through gravity, not through vibration. At an even larger scale, stars are organized within galaxies. Galaxies themselves are bound by gravity and structured by the distribution of mass. Spiral galaxies, like the Milky Way, have rotating arms. Elliptical galaxies have more uniform shapes. Irregular galaxies lack a defined structure. Each type reflects a different history of formation and interaction. Galaxies can also interact with one another. They may pass close, distorting each other's structure. Tidal forces can stretch streams of stars and gas, creating elongated features. In some cases, galaxies merge. This process occurs over long timescales. Stars rarely collide directly. due to the vast distances between them. Instead, their paths are altered, orbits shift, structures change, new patterns emerge. Gas clouds within the galaxies may compress, leading to new periods of star formation. All of this unfolds without sound, even at this scale, where entire galaxies interact. There is no medium to carry vibration. The energy involved is immense. The structures affected are vast, yet the universe remains quiet. The absence of sound does not limit interaction. It simply changes how that interaction is expressed. Instead of waves in a medium, the universe relies on forces, fields, and radiation. Gravity acts across distance without requiring contact. Light carries information without needing a substance to move through. Particles travel through space, interacting when they encounter one another. These mechanisms allow for continuous activity without producing sound, even in the most complex systems where multiple stars interact, where galaxies merge, where structures evolve. The silence remains unbroken, not because there is no motion, but because motion does not organize into vibration on a scale that can propagate the universe at every level, from individual stars to entire galaxies, is filled with structure, with interaction, with continuous change, all unfolding in complete and uninterrupted silence. Stars are not permanent objects. They exist within a defined life cycle, one that is shaped by mass, composition, and the balance between gravity and energy. At the beginning of this life cycle, a star forms from a collapsing region of gas and dust. At the end, that same star no longer maintains the balance that once sustained it. Between these 2 points, the structure of the star changes in measurable and predictable ways. The earliest stable phase of a star is often referred to as its main sequence stage. During this time, the star fuses hydrogen into helium in its core, producing energy at a relatively steady rate. This phase can last for a significant portion of the star's total lifespan. The duration depends primarily on mass. More massive stars consume their fuel more rapidly. They produce more energy, but exist for shorter periods. Less massive stars burn more slowly and can persist for far longer. As hydrogen in the core becomes depleted, the structure of the star begins to change. Fusion in the core decreases, reducing the outward pressure that once balanced gravity. Gravity begins to dominate, causing the core to contract. As the core contracts, its temperature increases. This rise in temperature allows new fusion processes to begin in surrounding layers. The outer regions of the star respond differently. They expand outward, increasing the star's overall size. This phase produces what is known as a red giant. The star becomes larger, cooler at the surface, and often more luminous. The expansion is not explosive. It occurs gradually, over extended periods of time. From a distance, it appears as a slow transformation. No sound accompanies this change. The movement of material, the shift in structure, the increase in size, all occur without vibration, propagating outward. As the star continues to evolve, the processes within its core become more complex. Heavier elements may begin to form, depending on the mass of the star. In stars with sufficient mass, fusion can proceed through multiple stages. Each stage produces different elements and requires increasingly high temperatures. Eventually, the star reaches a point where further fusion is no longer possible. At this stage, the balance between gravity and energy can no longer be maintained. The outcome depends on the star's mass. For stars similar to the Sun, the outer layers are gently expelled. This material moves outward, forming a cloud of gas. The remaining core becomes a dense object known as a white dwarf. The white dwarf no longer undergoes fusion. It gradually cools over time, radiating away its remaining energy. The surrounding cloud, often called a planetary nebula, expands into space. It may be illuminated by the central remnant, creating a visible structure. But even in this expansion, there is no sound. Material moves outward, spreading into the surrounding space, yet without a medium. There is no propagation of vibration. In more massive stars, the final stages are more dramatic. The core collapses rapidly, as gravity overcomes all opposing forces. This collapse can occur in a very short time. The outer layers respond by being expelled outward. This event is known as a supernova. The energy released is extremely large. For a brief period, the star may outshine entire galaxies. Light travels outward, carrying information about the event. Shock waves move through nearby material, compressing gas, triggering new processes. But beyond the immediate region, there is no sound. The explosion is visible, but silent. The remnant left behind depends on the remaining mass. In some cases, it becomes a neutron star. A neutron star is extremely dense. Its mass is comparable to that of a star, but compressed into a much smaller volume. The structure of matter within it is fundamentally different. Particles are packed closely together, forming a state unlike that found in ordinary matter. Some neutron stars rotate rapidly. As they rotate, they emit beams of radiation. If these beams are aligned with Earth, they appear as regular pulses. These objects are known as pulsars. The pulses are precise, occurring at consistent intervals. They can be measured with high accuracy. Yet, the pulses are not sound. They are signals in radiation, translated into data. Even in these highly structured systems, the silence remains. In the most extreme cases, the remnant becomes a black hole. At that point, the structure of the star is no longer visible. Matter collapses beyond a threshold from which no light can escape. The processes that occur within are not directly observable. The transformation from a massive star to a collapsed remnant represents a complete change in structure, from a diffuse, luminous object to a compact, dense form, all of it unfolding without sound across all these stages, from formation to stability to transformation. The structure of stars changes. Their size, their temperature, their composition, each evolves over time. These changes follow physical laws. They can be modeled, predicted, and observed through light, but never heard. The life cycle of a star is one of continuous transformation, a process that spans millions or billions of years, marked by changes in structure rather than sound. And as each star follows its path, forming, shifting, ending. The universe continues to fill with new material, new structures, and new stars, all emerging from the same quiet processes, repeating across space without ever producing a sound. The space between stars, though vast and often described as empty, is part of a larger structure. Stars are not scattered randomly. Through an infinite void, they are organized, arranged within systems that extend far beyond individual stellar neighborhoods at the largest observable scales. Stars exist within galaxies, and galaxies themselves form patterns. These patterns are not immediately visible. From a single point of view, they emerge only when observing large regions of space. Galaxies tend to group together. Small collections, known as galaxy groups, contain a few dozen galaxies. Larger structures, called clusters, can contain hundreds or thousands. Beyond clusters, there are even larger arrangements, known as superclusters. These are not tightly bound systems, but extended regions, where galaxies are more densely distributed. Between these structures, there are vast regions with very few galaxies. These regions are often referred to as cosmic voids. A cosmic void is not completely empty. There may still be gas, dark matter, and occasional isolated galaxies, but compared to surrounding regions, the density is extremely low. These voids can span tens or even hundreds of millions of light years. They represent some of the most sparsely populated areas in the universe. From a structural perspective, the universe resembles a network. Galaxies and clusters are connected by filaments, elongated structures composed of matter. These filaments form a web-like pattern, often referred to as the cosmic web. The spaces between the filaments are the voids. This arrangement emerges from the way matter has evolved over time. Small fluctuations in density in the early universe grew under the influence of gravity. Regions with slightly more matter attracted additional material. Over time, these regions became the structures we observe today. The process continues. Matter still moves, though slowly, toward areas of greater concentration. Structures evolve, clusters interact, filaments shift. Yet, even at this scale, there is no sound. The distances involved are too large. The density of matter is too low. There is no continuous medium linking these regions. Motion occurs, but remains unconnected in terms of vibration. The cosmic web, though vast and dynamic, is silent. Even within galaxies, the distribution of stars follows structure. In spiral galaxies, stars are arranged in rotating arms. These arms are not fixed objects, but regions of higher density. Stars move through them, entering and leaving over time. The arms themselves persist as patterns within the galaxy's rotation. This rotation is gradual. The sun, for example, takes hundreds of millions of years to complete a single orbit around the center of the Milky Way. From a human perspective, this motion is imperceptible. It appears as stillness, but in reality, everything is in motion. Stars move along their paths, influenced by gravity, interacting with the overall mass of the galaxy. This motion does not produce sound. There is no medium through which it can propagate. Instead, the structure of the galaxy is revealed through observation of light. Differences in brightness, color, and position provide information. These observations allow astronomers to map the structure of galaxies, to understand their rotation, and to infer the presence of unseen mass. Much of the mass within galaxies is not directly observable. It does not emit light or interact with radiation in a detectable way. Its presence is inferred through gravitational effects. This unseen component is often referred to as dark matter. Dark matter does not produce sound. It does not emit light. Its influence is felt only through gravity. It contributes to the structure of galaxies and clusters, helping to hold them together. Without it, the observed motion of stars would not match the visible mass. Even this hidden component, which plays a major role in shaping the universe, operates silently. It interacts without vibration, without emission of sound. without any audible signal. The structure of the universe is therefore defined by forces that do not rely on sound. Gravity shapes motion. Energy defines behavior. Light carries information, but sound requires conditions that are rarely present at every scale, from the smallest structures within a star to the largest patterns spanning the cosmos. The same principle holds. Motion is present, interaction is constant, but the medium required to transmit vibration does not exist. The result is a universe that is structured, dynamic, and continuously evolving, yet remains completely silent. And within that silence, these vast patterns continue to shift, slowly, steadily, forming a structure that stretches beyond perception, held together by forces that move without sound and shape everything that exists within it. Distances in space are not measured in ordinary units, meters, kilometers. Even the distance between planets becomes too small to describe the separation between stars. Instead, distance is often expressed in terms of how far light can travel. A light year is the distance that light moves in 1 year, because light travels at a constant speed. This provides a consistent way to measure vast scales. Even so, these distances are difficult to fully imagine. The nearest star beyond the sun is over 4 light years away. This means that the light you see from that star began its journey more than 4 years ago. Many stars are much farther, hundreds, thousands, millions of light years away. At these distances, space between stars is not just empty, it is structured emptiness, regions with extremely low density, where particles are separated by large intervals. In such conditions, interactions between particles are rare. Motion exists, but it is not continuous across space. This lack of continuity prevents the formation of waves that could propagate. Sound depends on connection. A vibration in one region must pass to another through a chain of particles. Without that chain, The vibration remains local. It does not travel. In space, this chain is broken. Particles may move, but they are too far apart to transmit coordinated motion. Even when particles collide, the interaction is isolated. Energy is exchanged. Direction changes, but the motion does not spread. As a wave, the result is a form of motion that remains contained, localized, discrete, without extension. This is one of the fundamental reasons the universe is silent, not because motion is absent, but because motion does not organize itself into traveling vibration at larger scales. Distance introduces another effect. Even signals that can travel, such as light, become diluted. As light moves outward, it spreads. The same energy covers a larger area. Intensity decreases. A bright source becomes faint at extreme distances. Light may become so weak that it blends into the background. This creates a gradual loss of clarity, not a sudden disappearance, but a fading, a transition from defined signal to indistinct presence. In such conditions, information becomes harder to extract. Patterns are less visible, structures less distinct. The universe appears quieter, not because activity has stopped, but because its effects are no longer easily detected. This process is continuous. As distance increases, signals weaken. As signals weaken, the ability to observe decreases, and with that, the sense of quiet deepens. There are also limits to how much information can travel across space. Light carries energy, but it also carries detail. Subtle variations in intensity, in frequency, in timing, all contain information. Over long distances, these variations can become less distinct. Interference, dispersion, and interaction with matter can alter the signal. The original structure becomes harder to reconstruct. This introduces a kind of informational quiet, not complete silence, but reduced clarity. Signal that exists, but is no longer easily understood. At the same time, motion continues. Stars move through galaxies. Galaxies move within clusters. Clusters shift within larger structures. Each of these motions is governed by gravity. Gravity acts across distance without requiring a medium. It shapes trajectories, determines orbits, and influences structure. But it does not produce sound. It does not create vibration. That travels outward. Instead, it alters paths. The effect is continuous, subtle, and silent. Another important concept is the difference between local and large-scale motion. Locally, objects may interact directly. A star may influence nearby gas. A planet may affect surrounding particles. But these interactions do not extend far. They diminish with distance. At larger scales, motion becomes more independent. Objects follow paths determined by the overall structure. They do not transmit their motion to distant regions through vibration. Each system evolves largely on its own. This separation reinforces silence. Without strong connections between distant regions, there is no mechanism for sound to travel. Even in regions where matter is present, the density is often too low to support sustained waves. The interstellar medium, though not empty, is extremely thin. Particles are spread out, with large distances between them. A wave attempting to move through such a medium would dissipate quickly. Energy would be lost before it could propagate. This prevents the formation of coherent sound. The universe therefore operates under conditions that favor dispersion, not transmission. Energy spreads rather than remaining concentrated. Motion continues, but does not align into coordinated patterns that can travel. This leads to a consistent outcome: silence, not as an absence of activity, but as the natural result of how matter and energy are distributed across vast distances between isolated systems within regions of low density. The same pattern emerges. Motion exists. Interaction occurs. Structure evolves. But sound never forms. And as you imagine these distances, these immense separations, these regions where light itself fades, the sense of quiet becomes more complete. Not just a lack of sound, but a lack of connection. a space where motion continues without ever becoming shared vibration, and where everything that happens remains contained, unheard, and carried only by the slow passage of light. There is another way to understand the quiet of space, not through emptiness alone, but through the way motion itself is distributed across time. In everyday experience, motion often feels immediate. A sound is produced, and it is heard almost at once. A change occurs, and it is quickly perceived. In space, this immediacy does not exist. Every signal that can travel, light, radiation, particles, moves at a finite speed. This creates a delay between an event and its observation. The greater the distance, the longer the delay. This means that no event is experienced in real time across large distances. Everything that is observed is already in the past. A nearby star may be seen as it was a few years ago. A distant galaxy may be seen as it was billions of years ago. This separation between event and observation introduces a kind of temporal quiet. There is no immediate feedback, no instant awareness of distant changes, only signals arriving slowly across time. This affects how motion is perceived. Events that occur rapidly at their source may appear gradual when observed from afar. A transformation that unfolds over a short period can seem extended when viewed across distance. The result is a universe that appears calm, even when processes are complex and dynamic. This calm is not a lack of activity. It is a result of scale. Time stretches, signals delay, and motion becomes less immediate. Even within a single star, processes occur over long timescales. Energy generated in the core takes time to reach the surface. Changes in structure unfold gradually. From a distance, these processes appear steady. There are no sudden shifts, no abrupt transitions that can be perceived instantly, only slow evolution. This gradual nature contributes to the overall quiet, not because there is no change, but because change occurs in a way that resists immediacy. Another factor is the scale of motion itself. Large structures in the universe move slowly. Galaxies rotate, but over hundreds of millions of years. Clusters shift, but over even longer periods. These motions are continuous, but extremely gradual. To an observer, over a short time scale, they appear still. This apparent stillness is another layer of silence, not a true absence of motion, but motion that unfolds beyond the pace of human perception. At smaller scales, motion may be faster. Particles move, fields fluctuate, energy shifts, but these movements remain localized. They do not extend outward in a coordinated way. Without coordination, there is no wave. Without a wave, there is no sound, even in environments where matter is more concentrated, such as within stars. Motion is often turbulent, random, and unstructured. This randomness prevents the formation of coherent vibration. Sound requires alignment, a pattern of compression and expansion that repeats over time. In most regions of space, such alignment does not occur. Energy is present but distributed. Motion exists but not organized into sustained patterns. This leads to a form of activity that is continuous, yet unexpressed in sound. Another aspect of this quiet is the absence of reflection. On Earth, sound can reflect off surfaces, walls, ground, objects. These reflections extend the duration of sound. They create echoes, reverberation, layers of vibration. In space, there are no such boundaries. Even if a vibration could begin, it would have nothing to reflect from, no surfaces to return the wave, no structures to sustain it. The vibration would dissipate almost immediately. This absence of reflection contributes to the overall stillness. There is no buildup of sound, no accumulation of noise, only isolated motion that fades without extension. This creates an environment where nothing lingers, no echo, no reverberation, only the continuous passage of energy in forms that do not produce sound. Even the most energetic events do not leave audible traces. A supernova releases vast energy. But once the light has passed, there is no lingering noise. A star forms, a system evolves, but there is no accumulation of sound over time. Each event is self-contained. It does not contribute to a larger field of vibration. The universe does not build a background of sound. It remains clear, unfilled, quiet. This absence of accumulation is another defining feature. On Earth, sound can overlap. Many sources combine, creating a continuous environment of noise. In space, this layering does not occur. Each motion exists independently. Each interaction remains local. Nothing combines into a shared field of sound. The result is a universe where activity is constant but never overwhelming, a space where processes unfold without interference, where energy moves freely without generating vibration, and where time, distance, and structure combine to create a consistent and unbroken silence. And as these ideas settle, as the scale of space becomes clearer and the nature of motion becomes more distant, the quiet begins to feel less like absence and more like the natural state of everything that exists between the stars. When observing stars, what appears as steady light is the result of many overlapping processes. A star does not shine uniformly in every moment. Its surface is active. Energy rises from within, moving through layers of plasma, reaching the outer regions, where it is released. This movement is not smooth. It involves convection, where hotter material rises and cooler material sinks. These motions create patterns. On the surface of the sun, these patterns can be observed as granulation, small cell-like structures where energy is transported outward. Each cell represents a region where hot material rises, releases energy, and then cools and descends. The scale of these structures is large. Each one spans hundreds or even thousands of kilometers. yet from a distance, the surface appears uniform. This is another example of how complexity becomes simplified when viewed across scale. Stars also possess magnetic fields. These fields are generated by the motion of charged particles within the star. The interaction between rotation, convection, and electrical currents creates dynamic magnetic structures. These structures can influence the behavior of the star's surface. They can produce regions where activity is reduced or increased. On the Sun, these are visible as sunspots. Sunspots are cooler regions on the surface caused by concentrations of magnetic field lines. They appear darker because they emit less light. Their formation, movement, and disappearance follow patterns that can be studied over time. These cycles occur over years, reflecting changes in the star's internal dynamics. Even during periods of increased activity, the Sun does not produce sound that travels into space. The motion is real. The energy shifts are measurable, but the environment does not allow for vibration to propagate. In addition to surface activity, stars can emit streams of particles. These stellar winds consist of charged particles moving outward from the star. They travel through space, interacting with surrounding material. When these particles encounter a planetary magnetic field, they can be guided toward the planet's poles. This interaction can produce visible effects such as auroras. On Earth, these appear as shifting patterns of light in the sky. They are the result of energy interacting with the upper atmosphere. The process involves motion, collision, and emission of light. Yet, even here, the primary signal is visual. The energy is not transmitted as sound across space. It becomes visible only when it interacts with a dense enough environment. This highlights another important idea. Sound can exist within certain environments, but not between them. Within a planet's atmosphere, vibration can travel within a star's interior. Waves may form, but between stars, between planets, between galaxies, There is no continuous medium. Each region is separated. Each system operates within its own conditions, and the space between them remains silent. There are also differences in how stars are distributed within a galaxy. The central regions often contain older stars. These stars may have formed earlier in the galaxy's history. The outer regions may contain younger stars, formed more recently from remaining gas. This variation in age affects the overall appearance of the galaxy. Color, brightness, and structure reflect the composition of the stellar population. Younger stars tend to be hotter and appear bluer. Older stars are often cooler and appear redder. These differences are subtle at great distances, but measurable. They provide information about the history of the galaxy. Even as stars age, move, and change, the overall structure remains quiet. No signal travels through the space between them. In the form of sound, the information is carried through light, through motion, through gravity, but never through vibration. Across a medium, this consistency extends across all observed systems, from individual stars to clusters to galaxies. The same principle holds. Motion does not become sound. It remains contained, localized, and expressed in other forms. Even the most active stars, those with strong magnetic fields, rapid rotation, or intense energy output, do not break this pattern. Their activity is internal or confined to their immediate surroundings. It does not propagate outward as a wave of pressure. The universe continues to operate through these silent processes. Energy flows, matter moves, structures evolve, all without producing the kind of vibration that would be heard. And as you imagine these stars, their surfaces shifting, their energy rising and falling, their light traveling outward, it becomes clear that even in the presence of constant activity, the silence remains complete, not as an absence of motion, but as the natural result of how that motion exists, contained, distributed, and never organized into sound, across everything you've considered: stars, space, distance, motion. A pattern begins to form, not a visual pattern, but a structural one, a consistency in how the universe behaves. Stars form through gradual collapse from diffuse clouds of gas and dust. They ignite, not with a sudden sound, but through increasing pressure and rising temperature. They stabilize, balancing gravity and energy for long periods of time. They evolve, their internal processes shifting, their outer structure changing, their energy output adjusting. They end, not with noise, but with transformation. Material moves, light expands outward, structure rearranges. At every stage, there is motion. At every scale, there is activity. But nowhere does that activity organize itself into sustained sound. This is not an exception. It is the rule. The universe is not occasionally quiet. It is fundamentally structured in a way that produces silence. Sound requires alignment, a sequence of particles, each passing motion to the next, creating a wave that can travel. But in space, that sequence does not exist. Particles are separated. Motion remains local. Energy moves, but not through compression and expansion of a shared medium. Instead, it travels as radiation or as the motion of individual particles or through the influence of gravity. Each of these forms of motion operates without sound. They are complete in themselves. They do not require vibration to exist or to carry information. Light travels without needing matter. Gravity acts without needing contact. Particles move without forming continuous chains. These mechanisms define how the universe functions, and because of them, silence is not a limitation. It is a consequence of efficiency, a system where energy moves freely without resistance, without interference, does not produce sound. It produces clarity. Light moves in straight paths, unless influenced by gravity. Signals arrive without distortion from a medium. Energy is not absorbed by surrounding material because there is so little of it. The quiet of space allows for direct transmission, not of sound, but of information. And even that information is shaped by distance. As signals travel, they weaken, they spread, becoming less concentrated. Their detail fades. What begins as a strong signal gradually becomes subtle, and beyond a certain point, it may no longer be detectable. This introduces another layer of quiet, not just the absence of sound, but the fading of information itself. Regions of space become disconnected, not by barriers, but by distance. Light may take so long to travel that by the time it arrives, the source has changed, or the signal may never arrive at all. This creates boundaries within the universe, not visible boundaries, but limits on interaction, limits on what can be known. Within these limits, each region continues. Stars burn, galaxies rotate, structures evolve, but not all of it is shared, not all of it is observed, and none of it is heard. Even within a single system, there is separation. A star emits energy, but the space between it and another object remains empty. A planet orbits, but does not transmit its motion outward as sound. Each system is self-contained, connected through gravity, through light, through motion, but never through vibration. Across a medium, this creates a universe that is both connected and isolated. Connected through forces that act at a distance. Isolated in the sense that each interaction remains local. The result is a form of quiet that exists everywhere, not just between stars, but within the structure of space itself. Even at the smallest scales, this quiet persists. Particles interact, fields fluctuate, energy shifts, but these interactions do not form waves that can travel. They remain confined to the scale at which they occur. At larger scales, the same pattern continues. Structures form, but are separated. Motion exists, but is not transmitted. Energy flows, but does not create sound. Across all scales, the same conditions apply. And because of this, The universe maintains a consistent state of silence, not interrupted, not broken, but continuous, a quiet that does not depend on stillness, a quiet that exists even as everything moves. And as you consider this, as the ideas begin to settle, the scale of it becomes clearer, distances that extend far beyond familiar reference, time that stretches across billions of years, structures that form, shift, and change, all without producing a single sound, only light, traveling steadily, carrying information across space, only gravity, guiding motion without contact, only particles moving independently without forming waves, and within all of it, space, open, unfilled, allowing everything to exist without overlap, without noise, without interruption, a kind of stillness that does not require the absence of motion, but exists because motion does not become sound. And as you imagine this, not as an abstract idea, but as a physical reality, a space where everything continues without urgency, without signal, without noise, the quiet begins to feel less like something missing and more like something present, a steady condition, a background that does not change, a space where processes unfold without needing to announce themselves, where nothing demands attention, where everything exists at its own pace. And as that pace slows, as the scale expands, as the distance settles in, the details begin to soften, edges become less defined, structures fade slightly into the background, light becomes more diffuse, and the vastness of it, the distance between things, the separation of systems, begins to feel less like emptiness and more like openness, a space that allows everything to continue without pressure, without interruption, without sound, only the steady movement of energy, of matter, of time, unfolding without urgency, incomplete and continuous silence